Welcome to section 10.4, hypothesis testing for matched or paired samples. How is this different from what we have done before? Well, what we are doing now is we are testing pairs of samples. So this is going to be like a before and after experiment. And the subjects are matched in pairs, usually the subjects with themselves. And we're going to have two samples and differences are going to be calculated. Once we compute that difference, that's really what we're going to be doing our hypothesis test. It's really just the test of a single mean. We're going to use the symbol mu sub d to represent the population mean difference. And we're going to use the student's t-distribution with n minus 1 degrees of freedom. So let's go ahead and do an example. A study was conducted to test the effectiveness of a juggling class. Before the class started, 6 subjects juggled as many balls as they could at once. After the class, the same 6 subjects juggled as many balls as they could. The differences in the number of balls are calculated. The differences have a normal distribution. We want to test whether the juggling class was effective at a 1% significance level. Fun fact here, I actually did take juggling classes when I was in college. Anyway, let's go ahead and look at our data. So across the top, you see these are our subjects, A, B, C, D through F, and this was how many balls they could juggle before the class, and this is how many they could juggle after the class. All right, the first thing we're going to do here is we're going to compute the differences for each of these. We're going to take after minus before, and that's going to be our value for the differences. None of these are negative, but they could be, okay? If somebody got worse after the juggling class, I don't know, maybe they injured themselves, but they didn't in this example. And the data for the differences is down here in this data set, 1, 1, 3, 2, 1, 2. And this is really the data set we're going to work with from now on. The first step in this one, we're going to have a little step 0 for this hypothesis test as well, is we need to compute the differences, which we did, and then we need to compute their sample mean and standard deviation. So you can use any method you like to calculate their sample mean and sample standard deviation. I used Desmos to calculate them. I got the mean was 1.67 and the sample standard deviation was 0.816. And of course, there are 6 items in that list. You could use Excel too. What are the null and alternative hypotheses? So the question is, after the class, could they juggle more balls than they could before? Is after minus before greater than 0? So the null hypothesis means that they stayed the same or they decreased. And the alternate hypothesis would be that they improved, okay? So when I was actually writing this up, I would actually probably start with the alternative hypothesis is after minus before greater than 0. Remember, after minus before, that's going to be my average value of that is going to be my mu sub d, my differences mean. And I want to know if that's greater than 0, if the class actually helped or not. Since that's got a greater than sign and no equal sign, we can't have that be our null hypothesis. Our null hypothesis has to have something we can assume about the distribution. We need to have an equal sign in there. So our null hypothesis is that they juggled the same or fewer, and our alternative hypothesis would be that they improved. All right, let's find the appropriate distribution and write down what we know. We don't know the population standard deviation, so we use the student's t-distribution. We have this data, and remember the n was 6, so the degrees of freedom are going to be 5. This really, at this point, is going to feel really the same as testing for a single mean, because it really is the same as testing for a single mean. We go to our online calculator, put in sample statistics. We're down to 1 sample now because we're really just testing the differences. Our null hypothesis mean was 0, and we're doing a student's t-test. The alternative hypothesis was that it would be greater than. If we go back, we can double check those, 0 and greater than. Our sample size was 6, sample mean 1.67, sample standard deviation 0.816. Hit calculate, and we get some results. Our test statistic value was 5.013. If they ask you to enter that in the homework, that's where you would find that. The p-value is 0.002, and the degrees of freedom is 5. We wanted to test this at a 1% significance level, so alpha is equal to 0.01, and this is a right-tailed test because the alternative hypothesis had a greater than symbol. So the p-value, 0.002, is lower than the alpha, so the null must go. Remember, the null was that they stayed the same or they didn't improve. So our test suggests the data supports that the juggling class does improve the number of balls that a person can juggle, right? That's the alternative hypothesis, that they were able to juggle more balls after taking the juggling class. So again, this process is really similar to the hypothesis testing for a single mean because we really just take the differences and now we reduce it to a sort of single mean problem. That's it for this section. Short sections today. The problems on the homework might take a little bit longer because there's some computation to do, but really no major new